This is the part 2 for orbital overlap and hybridization. At the end of the lesson, you should be able to draw and explain the formation of hybrid orbital for the central atom, and there are sp, sp2, sp3, sp3d, sp3d2 of hybrid orbital, and you will learn a few appropriate examples. What is hybridization? It is a process of we mix two or more atomic orbital, which is the SPDF orbital that we already learned before this, that have similar energy, means same quantum number. Kalau kita nak mix, mesti 2s dengan 2p. Dia tak boleh 1s dengan 2p. Mesti same quantum number in an atom to form a new set of hybrid orbital. Kita totally form a new orbital. The new atomic orbital produced, kita panggil dia sebagai hybrid orbital. The new set of hybrid orbital mesti ada same shape and energy. So let's recall, we have this example of atomic orbital, spherical for s orbital, and then dumbbell untuk p orbital, and then we have cloverleaf and the donut ring. Okay, so what does it mean with same energy? I mean that if you want to mix the orbital and you want to form new hybrid orbital, mesti yang same level, n equals to 3 contoh. Barulah you can mix this and you will form new hybrid orbital. There are 5 common types of hybrid orbital that you will learn. So first, you have sp hybrid. Next, you have sp2, sp3, sp3d, and the last one is sp3d2. So how can you form all of these hybrid? First, for sp, okay, kita tengok the first case sp dulu. S combine with 1p orbital. So, take out your pencil and tulis together with me. S plus p. Dapat sp. So, next one, sp2 pula. Kita consider sp2. S plus 2p orbital. So, tulis p tambah p. So, you will total up jadi sp2. Okay. So, next, sp3 pula. For sp3, you have s plus 3p orbital, means tambah p, tambah p, tambah p, and then you get this new orbital lah, sp3. Next, if you want to form hybrid orbital of sp3d here, means you need to mix s plus p, p, and another p, okay, and you have 1d here, plus d orbital, okay. Last, if you want to form this sp3d2, you need to mix together all the orbital of s plus 3p orbital plus d plus d. Then you will have this new hybrid. You call it as sp3d2. So, ini adalah nama-nama kepada hybrid orbital yang baru kamu form. Alright, so focus on this part of the table. You have orbital arrangement. Okay, so this one is, you can relate back to VSEPR, valence shell electron pair repulsion. So, when you form this hybrid orbital, all the electron pair will arrange themselves as far as possible according to VSEPR. So, they will arrange themselves in the space as far as possible to sama juga to minimize repulsion between the electron. Okay, so that is why for sp hybrid, you will get orbital arrangementnya adalah linear, and then for sp2, you will get trigonal planar, and then tetrahedral, trigonal bipyramidal, and octahedral. So ini semua adalah back to the basic shape. Okay, so we will look into detail with few extra example so that you can see the concept. Okay, I give you an analogy. Nak menceritakan yang bila kita mix orbital, pure orbital yang kita dah belajar before this, S, P, D and F orbital tu, kita akan dapat a new set of hybrid orbital. Dia totally a new shape. Okay, dia masih lagi orbital tapi new shape. And syarat untuk mix the orbital mestilah same energy level. Maksudnya sama value N dia. Principal quantum number dia mesti sama. Okay, so let's say I give you an analogy. I have 3 room to be painted. Okay, means ada 3 bilik. Satu bilik pertama I've settled with cat warna biru. Okay, and then the second room I've settled with cat warna merah. And then the last room, Miss hanya tinggal 2 tong cat, and which is ada tong cat biru dan 1 tong cat merah. Okay, takkanlah Miss nak cat the last room, it's just a small room, imagine. Takkanlah Miss nak catkan half of the room merah, half of the room biru. Okay, it's gonna be a bit unpleasant. It is going to be a bit weird. So, I've decided untuk mixkan with red color. Okay, tadi ada 1 tin biru, 1 tin merah. Instead of Miss colorkan dia half biru, half merah. Okay, I've decided to mix them. So, Miss masih lagi ada 2 tin cat, amount cat yang mencukupi untuk cat the whole room. And then, I will get a new set of color, which is purple paint. Okay, masih lagi dapat amount yang sama, 2 tong cat. It is totally a new thing form. Okay, so macam tu lah juga, I want to explain to you the concept of mixing orbital. Let's say I have S orbital, 1 S orbital. Okay, 1 S orbital bentuk sphere. And then I have P orbital, 1. Tak kisahlah mana-mana orientation. So you have S dan P mixed up together and you will get a new set of orbital here. Okay, so new form ataupun new shape of this orbital kita akan tengok after this. Let's have a look at sp hybrid orbital. To form this sp hybrid orbital means you need to mix S and one of the p orbital. So to make you understand this concept, I'll just illustrate here. Let's say you have S, okay, P you have 3 orientation, and D orbital 1, 2, 3, 4, 5 D. Okay, so if you want to form this sp hybrid orbital, means you need to mix S and P. So I'll highlight here, you want to form sp by mixing S, 1 S orbital and 1 P orbital. So if you mix together these two, okay, you will have mixture of S orbital and P orbital in dumbbell, S orbital in sphere. You will get a new shape molded here, which is 2 sp hybrid orbital. Okay, in terms of tulisan, kita akan tulis macam ni lah. You mix these two, you will have two new orbital. Namanya adalah sp dan ini pun namanya sp orbital. It is no longer pure orbital spdf tu. It is completely a new orbital and this is for each sp hybrid. Shape-nya begitu and bila dia punya arrangement by considering VSEPR, by considering the valence shell electron pair repulsion, since dalam orbital ini ada electron, so they will arrange themselves as far as possible to minimize repulsion between electrons. Okay, so you will have two sp hybrid orbital arrange themselves as far as possible, and this shape will be according to the electron pair geometry, which is basic shape. Ini adalah linear. Okay, sebab dia akan susun sejauh mungkin. And how can we view this? Okay, one of the sp hybrid orbital, ini satu orbital ya. Okay, dia akan combine and ini. Yang Miss highlightkan warna kuning ni. Okay, the next one, color in blue. Another one. Ini ada small lobe di sini kan. So, dia akan combine together and arrange themselves as far as possible. Lobe kecil tu masih ada, cumanya it will be hidden. Okay, dia agak tersorok ataupun insignificant because the size is too small. And bila kita nak draw, dalam drawing, it is impossible for us to draw it. Okay, kalau dalam bentuk 3D model, kalau guna simulation, it is possible lah to portray it. But then, in terms of drawing, since it is too small, so we just abaikan dia, neglectkan dia. When you draw, just straight away draw. Ada dua lobe, satu, and then label SP, and then another lobe, kita draw asing. Okay, label pun asing, SP. Okay, so ngam lah. One SP here. Okay, one SP, two SP orbital. Maksudnya setiap satu platform ni atau satu orbital, satu lobe. Satu orbital, another lobe. Okay. So, you can also write this to, okay, sorry. You can also write this in this form. Okay, tuliskan dia punya orbital, buatkan bracket, tulis terus di bawah sp orbital, hybrid orbital. Next, we look at sp2 hybrid. So, sp2 hybrid orbital, we need to form by mixing S plus P orbital and another P orbital. So, kamu akan dapat sp2 hybrid orbital. So, one S orbital mixed with one P orbital and another P orbital. Kamu akan dapat this sp2 hybrid orbital. Okay, so ini adalah dia punya new shape. Okay, kamu akan ada 3 sp2 hybrid orbital. Okay, so maksudnya ini. Okay, generally kamu akan ada sp ada 3 kan? D, 1, 2, 3, 4, 5. Okay, so bila Miss cakap, it's a mixture of S, 1 s orbital and 2 p orbital means kamu akan gabungkan this 1, 2, 3. 3 ni akan digabungkan jadi a new orbital. Okay. So 1 s orbital, 1s ini, and then 2p orbital, 1, 2. And then kamu akan dapat 3 kan? 3 new orbital which is sp2 nama dia. sp2 ni adalah nama of the new orbital tu. And you have 3. 1, 2, 3. And then means bila kamu nak tulis, dia akan jadi begini. 1, 2, 3. Ini orbital yang baru ini namanya adalah sp2 hybrid orbital. Okay, itu cara tulisnya. And macam mana pula dengan dia punya shape? Okay, all this, since kamu ada 3 kan, 1, 2, 3. Okay, imagine in 3D, all the electron repulsion dia akan susun sejauh mungkin due to the VSEPR. Okay, kalau ada 3, ingat balik hari tu kita belajar basic shape. Kalau ada 3 electron pair, dia akan jadi AB3 kan. AB3 which is the basic shape is trigonal planar. Okay, so means bila kita ada 3 sp2 hybrid orbital, dia akan ikut the shape of trigonal planar sebab elektron akan susun sejauh mungkin to minimize the repulsion. So I will highlight. Okay, so the first one ini, misalkan guna warna kuning. So this is the first one. So you can see the first one. And then this is the green one, the second one. Dia di sini positionnya. It will arrange themselves as far as possible. And the last one here, di sini, to minimize the repulsion. So when you want to draw this hybrid orbital, 1. Okay. And the label dia adalah sp2. sp2, sp2. Okay, so there you go. Trigonal planar dengan bond angle 120 degree. Since it is very impossible for us untuk show the bond angle accurately, so what we can do is, dekat, if you were asked to show the bond angle, is either you label dekat sini, dekat between the orbital here, ataupun you just remark di bawah, bond angle-nya adalah 120 degree. Okay, later I will show you the correct way untuk jawab this type of question lah. Next, we will look at sp3 hybridization. It is a mixture of 1s orbital we mix together with 3p orbital, and then we will get the new hybrid orbital as 4 sp3 hybrid orbital. So that's 1, 2, 3, and 4. You have here 4 hybrid orbital. So let's say you have S, P, and D orbital. Okay, so for S orbital, you have one. For S orbital, you have one orientation here. P, you have Px, Py, and Pz. and D you have 5 here because of the orientation of the orbital. There are 5 in total. So when you are mixing together to form this sp3 hybrid, you are mixing one s orbital and with 3 p orbital, 1, 2, 3. Therefore, you will get the result as 1, 2, 3, 4, and all of them are called as sp3 hybrid orbital. And for this sp3 hybrid orbital, it will adopt, so you can see the wording here, they can adopt tetrahedral geometry. Why? Because you have here 1, 2, 3, 4 electron pair. Therefore, each electron will be positioned in each of these orbital. 1, 2, 3, 4 here. When you have electron will arrange themselves according to VSEPR theory, Vesper theory. Therefore, you will have the orientation of the electron as tetrahedral geometry, and the bond angle will be 109.5 degree at each bond. Next, to form sp3 hybrid orbital, you need to form them by mixing s, p, 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 and d orbital. Therefore, you will form new sp3d hybrid orbital, and there are 5 of them. So, you will write them like this. You have S, 1, 2, 3, 4, P, 1, 2, 3, 4, 5, D. Okay, you have 1S, 3 of the P. You have here 1S orbital and 3 P orbital. You will combine with any of the D orbital in any orientation, so we just choose 1. Therefore, in total, you will have them as 1, 2, 3, 4, 5, and all of them here are labeled as sp3d hybrid orbital. And since you have 5 electron pair here, therefore your shape will adopt the geometry of trigonal bipyramidal geometry. The last example for the hybrid orbital is sp3d2 hybrid orbital, and in order to form this new hybrid orbital, we need to mix one s orbital with 3 p orbital and together with 2 of the d orbital. Therefore, you can generate 6 sp3d2 hybrid orbital. So, it will be like this. I will show you. So you have S, P, D. Okay, so 1 S, 3 of the p orbital, and d orbital you have 5 of them. So if you want to form this sp3d2, means you have to combine all of them S, P, 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 D, and another D. Therefore, you will form a new set of hybrid orbital, and there are 6 of them. 1, 2, 3, 4, 5, 6. Okay, so all of them are sp3d2 hybrid orbital. And since you have 6 pair, therefore each of the orbital here, they will arrange themselves as far as possible from one another. So you have 6, 1, 2, 3, 4, 5, and 6. And all of them will arrange themselves as far as possible according to this Vesper theory to minimize the repulsion between the electron. And they will arrange themselves and adopt the geometry of octahedral. And the bond angle will be 90 degrees.